Fine, guys. Let's start. Yeah. So yesterday we have seen inheritance, and we are trying to understand the encapsulation, right? So let's try to understand. See, coming to encapsulation. So the actual encapsulation is it describes the idea of restricting access to methods and attributes. Okay. This will hide the complex details from user and prevent data from being modified by accident. Okay. So this is achieved by private methods or attributes under underscore or prefix or suffix. Okay. So here in encapsulation, what actually happens here is, so we are trying to mainly restrict the access to the methods and attributes in a class. Okay. So that means, for example, if we have the attributes over here in this class sensor. Okay, so we will try to restrict the access. So how we are going to restrict the access? For example, if you see here, yeah, so we are having self.name, self.location, self.version. Okay, this way, this is a class in initialization or constructor is defined. Okay, and now I am creating an object of this sensor class. Okay, with name and location. Okay, with name and location I am trying to create. Fine. So after that, if I want to access the name, I can do it by name. If I want to access by location, I can do it by location. But if I want to try to access by version, right? So you cannot access it by it directly. Okay, so this is actual encapsulation. So okay, you might find this as the in the abstraction, but actually that is not the core concept of abstraction. Okay, I will let you know. Okay, sorry for the confusion, but the in the abstraction part, uh, to make you understand the abstraction, we need to cover one more concept called as decorator. Okay, so I'll give a brief about the abstraction, but when I'm covering the decorator concept, I will come back to the abstraction part. Okay, but the actual encapsulation is this. Actual encapsulation is whichever, like when it is the method which will try to restrict the access of its attributes or methods. Okay, yeah, so the way how the way you can see here is, if you're having a single, sorry, yeah, single underscore, so still you can access the location as Berkeley. But for example, if you're having the multi, like double underscore, so it will, you cannot access it directly. Okay, but to access that in encapsulation, you need to give use two more methods inside the class. Okay, they are called getter and setter. Okay, they are called getter and setter. Okay, so getter function will help you to get the attribute, the private attribute. Okay, so as you can see, now in the getter function we can access the private variable. Okay, and if I try to do sensor one dot get version, so you will get it. You can access this through a method. Okay, and using a setter function you can set the values. Okay, using a setter function, sensor one dot set version 2.0. Okay, 2.0, right? If you set, it will set the value, and now when you again call the getter function, again if you call the getter function, it will give you the 2.0, right? So here what we are trying to do here is simple. Encapsulation means whatever the private variables which the class is owning. Okay, that private variables or methods, we are restricting it outside the class. Okay, to access it. But there is a point in encapsulation, it says that where was it? Yeah. Encapsulation prevents from accessing accidentally but not intentionally. Okay, so that means accidentally, if someone just creates an object and if they try to access the attribute, so it will restrict that. Okay, uh, it will restrict that. Fine, but not intentionally. Okay, but not intentionally. But intentionally, if you want to access, obviously you can. Huh? Yeah, so but intentionally, if you want to access, you can access it. How you can access it? Yeah, as I said, so if at all this car is class, car is an uh, class, and you can create an object over here. Okay, using double underscore method. Okay, the double underscore method, you cannot access it directly. Okay, but using the class underscore class name and the method name, you can access it. Okay, so these are two different examples if you observe. So here I am trying to access the attribute. What is my attribute? Version is my attribute. Okay, I'm not able to access that. Okay, it is saying no attribute. So for that, you can go for a getter function and a setter function. Okay, because it means that this value is a private value, and this is encapsulated for only this class. Okay, you cannot directly use it outside the class. Okay, to access that attribute, you not only this attribute, any attribute in the concept of encapsulation, you will always have two functions. One is called getter, one is called setter. Okay, these are general functions for a encapsulation concept. Getter will get you the attribute, okay, by using the self keyword, and setter will try to, if you want to set some value, you can set the value. Because outside this, with the help of an object, with the object reference, you cannot change the value of this variable. Okay, and you cannot access this. So that's why you need to use two functions, getter and setter. And this is for what? This is for the attribute level. Even for the method level also, if you want to restrict the access, okay, if you want to restrict the access directly, okay, if you want to restrict the access accidentally but not intentionally, okay, accidentally in the sense, what usually how they access, like object dot update software, so that you want to restrict. But intentionally, if you want to actually use it, they can go by what, they can use underscore car, that means class name, and underscore update software. Okay, that is a method name. Using that, they are allowed to do that. But just by the actual method name what they have defined, okay, they cannot do that. Okay, so that is a concept of encapsulation. Is this clear, guys? Yes, no?
Yes, Santosh.
Okay, fine. So next we are going to see something called as polymorphism. Okay. Now in polymorphism is see, the concept of polymorphism is simple. So it says a single method, okay, a single method or a single operator. Okay, if a single method, single operator can be used in different ways. Okay, can be used in different ways. Okay, for example, let's say, for example, you have a human being. Okay, you have a human being. Okay, so the same human being can act as a student, he can act as a father, he can act as a brother. Okay, he can act as a employee. Okay, the same guy, but his duty is changing. Okay, his function is changing according to the scenario, according to situation, right? So this is the basic concept of polymorphism. Okay, this is a basic concept of polymorphism. Okay, so now that is the concept of polymorphism. Okay, we'll see an example. And coming to the duck typing, okay, in duck, what does duck typing means in Python? Oh, sorry. Mm, yeah. So in Python, we are, you, as you might have observed till now, we are not defining the data type explicitly. Okay. In other programming languages, I think you need to say, if I create a equal to 10, you should also define a equal to int of 10. Okay, a equal to int of 10 in other programming languages. Most of the programming languages, we should also define the data type. Okay, but in Python, you don't need to do that. The moment when you say a equal to 10, it will understand it's an int. A equal to some hello, it will understand it's a string. That means what? It is a dynamic programming language. That the reason why Python is called dynamic programming language is Python itself understands according to how it is getting initialized or assigned. Okay, So but how it will know this, the given one is integer or string is, so it is called, the philosophy goes back to duck typing. Means if at all, if it walks like a duck, okay, if it walks like a duck and talks like a duck, it is a duck. Okay, there is a philosophy behind this duck typing. That means you don't know. Okay, for example, there is a bird. Okay, there is a bird. Okay, you don't know what is that bird. Okay, for example, similarly, you are creating an integer. Okay, so here you are not explicitly saying, hey, this 10 is an integer. You're not saying. Okay, here also, let's say there is a bird. Okay, there is a bird. Okay, you don't know what that bird is. Okay, now if at all this is walking like a duck and talking like a duck, then you will call this as a duck. Okay, based upon its what, based upon its nature, based upon its functionality, you will give a name. Okay, you will assign a name to it. Okay, but by default nobody is saying you what is this bird. Okay, similarly, like the reference to here, what I'm trying to bring to over here is, in Python also, nobody is going to tell to the Python programming language what data type they are creating. Okay, what data type they are trying to create. Okay, because based upon the assigning, okay, if it is looking like an integer and it can, if we can do integer operations on it. Okay, if we can do integer operations on it, Python will assign the data type as into it. We don't need to do it separately. Same way, why they're you calling it as a duck typing is, you will hear this word because the same thing. So it will say, it will assume that, okay, if at all I need to name a particular bird as duck. Okay, now user is not going to say me it's a duck or not. I will see this bird, if it is walking like a duck and talking like a duck. Okay, then I will, it should be duck. Okay, similarly, when given any variable. Okay, if it is, if it nature is looking like integer. Okay, internally according to its source code, right, it will internally assign it to the data type int. Okay, based upon the string. Okay, if it is able to do some string operations on it, Python internally understands this as string. Okay, so that is a small concept of duck typing. Okay, but coming back to polymorphism, as I said, it's a same method or same operator which will behave differently in different situations. Okay, so this is also not a new concept. We have already seen this concept, but we have not named it yet. Okay, for example, see here, let's say I'll show you a simple example. So we have a plus operator, right? So now in the plus operator, if I do 1 plus 1, what is the value? 2. Okay, it's adding. Okay, but if I say a, but same one, now what will be the answer? 1 plus 1. Now answer is 1 1, right? So here what it is doing, here adding, but here what it is doing, concatenating. Agree? So same operator plus, operator is not changing, same operator plus is acting differently in different situations. Okay, so if it is an integer, okay, if it is an integer, it will add. If it is a string, it is concatenating. Okay, this type of behavior is called polymorphism. Okay, because same guy exhibiting different behaviors. Okay, kind of aparichit. Okay, so same person is behaving differently. Here he is hiding, here he is concatenating. Okay, so now we'll see an example of this. Okay, similarly, as you can see here, so you can add two numbers. So if you pass 1 and 1, two integers will get 2. If you add two lists, okay, so it is just what it is doing, it is just extending the list, as you can see. Okay, see here, so here it's not concatenating a and d. So okay, it is concatenating, sorry, it is extending the list, first list, it is extending to next two elements. Okay, But in the third scenario, it is concatenating both the strings. Okay, that means the behavior of this place is changing according to the inputs that is passed. Okay, but the operator is same. Okay, in those this type of behavior is called polymorphism. Simple, poly is multi and this is behavior. Okay, so which exhibits multiple behavior in different situations. Okay, so now if I show here, so you are having a class as vehicle. Okay, you are having class vehicle class we are defining. Okay, and then you are doing what you are doing, uh, class of car, and you are inheriting the vehicle. Okay, you are inheriting the vehicle class here. Okay, and you have some functions over here. Okay, so yeah, this is a combination of inheritance and polymorphism. Okay, the way how if you are inheriting this one, then this is inheritance. But the way how you are where you are using polymorphism is here. If you see, I'm creating an object of car, I'm passing the parameters, I'm doing show, I'm trying to call the max, car max, and change gear. Okay. Now if I do car max, what I'm doing here, I'm calling this car max method. Okay. And the speed is 240. Okay. So it is printing initially car dot show. See, car dot show, obviously we don't have dot show in child class, so it is picking it from the parent class and it is initially printing these details. Okay, details, name, color, price, details, name, color, price. Okay, that's fine. But after that, if you see, I am calling car dot max speed. Okay, car dot max speed. Now car dot max speed, now the concept what we are trying to understand here is same method. Sorry, same method, max speed. Okay, but if it is in the parent class, its behavior is different. Okay, if it is in the child class, the result will be different. Okay, so that's why if you see, calling max speed from child class. Okay, calling max speed from child class and change gear from child class, call methods from car class, that means child class, it will behave differently. That means we have assigned this particular behavior to this function or method inside the child class. Okay, but the same method in the vehicle class will give you different results. Okay, so even though we are just using print statement over here, but you can write some functionality over here to return or to execute some expression. So the concept here is same method. Okay, same method can behave differently in different ways. Just like the place is acting differently, here the maximum speed is acting differently in different situations. Okay, that's a fundamental concept of polymorphism, nothing more. Okay, so if I show you one more example over here, this might be helpful. See, you are having class Ferrari, class BMW. Okay, so you are creating one object of Ferrari and one object of BMW. Okay, so now we want to, if you are, see, if you are iterating through Ferrari and BMW. Okay, if you are iterating through Ferrari and BMW over here, inside that, car dot fuel type. Okay, see, car dot fuel type, so it's the same fuel type, it's the same maximum speed. Okay, I'm using only one fuel type and maximum speed. But if my object is car, but initially this car will be Ferrari, right? So if my object is Ferrari, right, I am printing something, petrol and maximum speed 350. But if my object is BMW, I am printing diesel and 240. Okay, but the same method, as you can see, these two are the same methods which are behaving differently in different classes as per the object reference. Okay, so this type of concept is simply called as polymorphism. Okay, is this clear, guys?
Yes, sir, clear.
Okay, so Fine. So just to give an idea about the abstraction for now, okay, just for now. So actually abstraction is, uh, as per the definition. So what they are doing over here is, let me see abstraction. Yeah. So in abstraction, see what they are trying to do over here is they are using some abstract method. Okay. Now what is this abstract method is in Python, right? Sometimes you will come across a situation. Okay, you will come across a situation where you don't know the implementation. Okay, you don't know the implementation, but still you need to declare a method. Okay, such type of methods are called abstract methods. Okay, so which means what? Abstract methods has only declarations, but they don't have any implementations. Okay, so mostly if you see any examples of abstract, okay, what they are going to do over here is they are going to declare something called as abstract method, and they do it by concept called of decorator. Okay, so in Python, so we will study it in our next classes. So in Python we have a concept called decorator, and how you can use a decorator is this. What do you call this as a decorator? Okay, so here for example, if you have some class as test, okay, and inside that if you want to create an abstract method, so as I said, abstract method is here when you don't know the implementation. Okay, when you don't know the implementation, but you need to define a method. Okay, that means it is there will be only declaration. Okay, only declaration but no implementation. Okay, so in those cases you will go for the abstract method. Okay, for example, if I have class test, and the way how you can create an abstract method is you need to use a decorator called as abstract, okay, method. Okay, and then as I said, you don't know what you need to, what you want to implement, but you will just define it. So here you will have diff m1, okay, self. You will have pass. Yeah. So abstract method is not defined. Okay. So from, yeah. So that's, do we have something called as yeah. So in Python we have something called as ABC. In that we need to you will have the abstract method. Okay, so okay, so if I just do tab or right, so once you do from ABC import star, okay, then you will be able to access the abstract method. Okay, as I said, abstract is this is a decorator. Okay, so you will understand it more when we discuss the a decorator concept. But as of now, just try to keep in mind that abstraction abstract methods are those methods, okay, which are implemented without any functionality. Okay, so you are just using def m1 self, and you are just passing, you are just using pass. That means you want to define, so you want to define m1 class. Okay, m1 class in uh, test, m1 method in test class. Okay, but as of now you're not sure of what to implement. So okay, in that case what people are doing is they're using it as a placeholder. Okay, and they're passing uh, the pass keyword over here. And how this will work is I will explain you once we come to the decorator concept. Okay, so but as of now let's park this. Okay, so but apart from that, we have seen the inheritance. Okay, inheritance part, I think we are good. And coming to encapsulation, yeah, encapsulation is mainly hiding the what, hiding the attributes or methods, okay, from the class. Okay, and but it's not restricting us. It's only trying to give like more security. Okay, so you cannot directly access this. If you want to access it, you need to go by the getter function and the setter function. Okay, and same thing for the method also. Even for the attribute or the method also, you cannot directly access it. But if you want to access, you need to go by either getter or setter, or what, class underscore class name and the method name. Okay, in this way also you can access it. Okay, and next thing, coming to polymorphism. Yeah, duck typing is just a philosophy. In Python they just say it's a dynamic programming language, so that's why they use this. But polymorphism is the one which I told you, like same operator behaving differently in different situations, either it is plus or minus or some methods, okay, or some functions which behave differently in different scenarios. Okay, so that's a concept of polymorphism. Okay, so I would say that's all regarding the oops concepts in Python. So as I said, however, I will share you the complete material. Okay, so which is a huge material. You can go through that for better understanding and let me know any doubts. Okay, just if you want to expand your knowledge on this. Fine, fine, guys. So let me go to our next topic. So which is the exceptional handling. Okay, so exception handling is actually very important concept in Python. Okay, so let's start this. Are we good to start this, guys? Anybody any concerns?
Oh, sir, we can start.
Okay, fine. So see, exception handling is as I said, very important concept. But why? See, I was trying to give an introduction regarding this when I was starting oops, right? So pay attention, guys. So exception handling, because I think you will use this from the day one. Once you write starting code, uh, you will actually use it. Yeah, because see, now let's try to understand what is the fundamental concept of exception handling and what is an exception. Okay, see, as I said earlier, so once you start writing, right, so what you will do, you first line will be some imports. Okay, second line you'll write something, okay, like that. Okay, you'll use some functions, you'll define some functions. Okay, you will define some class. Okay, and then what you will do, some all those things. Let's say you are writing 100 lines of code. Okay, now the concept here is, and somewhere you are accessing some variables and you are returning some functions, everything, all sort of things you're doing. Okay, that is fine. Now there are two important points in every code. One is the execution or flow. Second thing is the result. Okay, second thing is the result. Okay, now in these two, the more priority is the flow. Second comes the result. That means executing all lines of code, all lines of the code, in the sense like what all lines that can be executed. Okay, that means I mean, if some condition, else some condition. Okay, in these two parts of code, on any one of the code gets executed, right? It's not both anytime. Okay, so what I mean by all lines of code is all the executable lines of code. Okay, as per the flow, what all should execute and what all must execute, those should be executed without fail. Okay, that is called normal execution. Okay, that is called normal execution. That means the flow did not break. Okay, the most important thing, okay, here it should be, the flow should not break at any time. Okay, the flow should not break, because once the flow breaks, then it causes actually a lot of issues. Okay, so initially when you even when you're trying to build any pipeline also, so they call it as a pipeline. Okay, so you might have heard you will use this word a lot once you start working in any project. So there it's a pipeline. Now, what is a pipeline? So you will have multiple teams, or even in single team also, you will have multiple tasks, and you will have like multiple what I say functionalities. Okay. So for example, let's say data collection could be one. Okay, data collection could be one code, and to this you will run it. You will, let's say you will run it in some AWS. Okay. Okay, AWS. For example, I will give my example. Okay, so I used to work on like AWS cloud. Oh, there we need to follow like different yeah, we used to have a pipeline. Okay, what's called, we will have different pipelines. So let me take first pipeline would be data ingestion pipeline. Okay, in the data ingestion or collecting pipeline, so we need to collect to some server. Okay, some AWS server, and I need to take the data, input the data. Okay, after that this output will be going to some other .py file. Okay, this will be, these are all .py files, these are all .py files. Okay, so once the data is collected, so here we will be doing some pre-processing. Okay, we will be doing some pre-processing. Okay, there will be some files. Okay, this will run, and after that then we'll be doing some training. Okay, you will be doing some training. Okay, so here the whole thing is called a pipeline, right? So ultimately, let's say ultimately here we are doing prediction. Okay, which is the end goal of my any machine learning project. Okay, we are doing the prediction. Now see here, starting from the data ingestion and reaching till prediction, the last end is the most crucial part. Okay, even if you are getting wrong predictions, that's fine. Okay, because the initial goal will be to have a complete running end-to-end flow. It's always called end-to-end flow, or shortcut it's called E to E. Okay, it's called E to E, end-to-end flow. Okay, initially you guys, if you're working from scratch in any project, so your goal will be to build a pipeline, the complete flow of the pipeline. Okay, end to end. That means it should have what all that's required for ingestion, the data accuracy and pre-processing, handling missing values, that's fine. Okay, even that are little not that perfect also, we can come back and tune. Okay, but initially you will try to like put a pipeline in place. That means to connect all the different .py files or different parts of this pipeline, and make sure if at all you are giving an input, if at all you are giving an input, the flow should directly pass through all the files and you should get an output. Okay, that's why it's called a pipeline. Okay, similar like a water pipeline. Okay, there should not be any leaks. If at all it is breaking over here, if at all it is breaking over here, for example. Okay, so then that's an issue. Then that is an issue anywhere. If it is breaking, it should not break, even if the results are very bad. Okay, initially you will have very 30% accuracy, even the results are very bad, then that's fine, still fine, no issues. But the pipeline should be well connected, and it should not break, the flow should not break. Okay, breaking the flow is one of the very critical issues in any problem, because if it is breaking, so you will not understand whether the issue is over here. If it is breaking, that's fine. Okay, it is issue, but what about the other code? Okay, which is coming after this. Okay, so that's why if it is flowing through starting till end, obviously you will know if whether there are any issues. Okay, what is the status of each and every file? Okay, what is the performance of each and every file? Okay, so that's why running end to end is very very important. Okay, so for that to make sure the flow is continued throughout the pipeline. Okay, we need to make sure that it is not breaking abnormally, it is not breaking abnormally. Okay, normal execution is completing the full flow, abnormal execution is breaking somewhere. Okay, so but why does it break? Okay, why does it break? Because there could be many reasons, right? There could be many reasons, right? For example, if I show you a simple example, as I'm showing here. So I'm saying a equal to 10. Okay, and I will try to print a, so it will break, because what I'm doing, so it's a simple syntax error. Okay, simple syntax error. So what happens over here is, if I am in the whole 1,000 lines of code of your project, okay, if somewhere, okay, everything is fine, everything is fine, perfect, but somewhere you have done is this silly mistake, 10, instead of doing this, you just did this by mistake. Okay, then what happens? it will break here. Let's say this is at the 555th line. This will break here and complete execution stops post this. Agree? That then that's an issue, right? Obviously. So that's the reason, if at all, keeping in mind, if at all, if you might face some issues like this, right, then you should be ready to handle this so that you can just bypass this and go to next line. Okay, so that should be your design. Okay, so okay, fine, we don't know in the runtime. So while training will take utmost care, but when you are deploying and when you are okay, in the during the runtime, so the model or the code runs on the dynamic data. That means what? On the actual user data. And we cannot be 100% sure all the time what type of the data the user will inject, right? While training, it is very fine and cool, because you have the data available in your system. You can analyze each and every column, you know what is a structure, distribution, everything, you know, because the data is in front of your eyes. Okay, you can handle that and then you can train the model. That's fine. But after training, you're not keeping the model with yourself, right? Obviously, you need to provide it to some persons. Okay, let's say you have deployed it in some web application. Now, that will be used by some unknown persons. He will input his data as per his vision will. Okay, and we cannot be always sure that there will not be any mistakes in the during the input phase. Okay, so let's say he might give some data like this. Okay, because let's say somewhere you are saying enter input. Okay, if he's giving in this way, obviously that will raise an issue. Okay, so in these scenarios, if it breaks here, so complete execution comes to halt. Okay, so that what will be the scenario over here? So there could be two things. You can raise a warning. You can ask him, hey, this is not a proper input. Or if it is unsolvable issue, the design should be, you should just bypass that step and go to next step. Okay, if it is failing here, okay, go to 556. Okay, but the flow should continue. You should come till 1000 line. Then only you will know where all the gaps are, so that you can come back and fix them. Okay, so the issues which you are facing over here, which breaks the flow, are called exceptions. Okay, all the issues which try to break the flow are called exceptions. Okay, whenever the exception is raised, Python immediately stops over there. Okay, even if you run like 10 different lines, and if the issue is at the first line, it will immediately stop, it will come to halt. Okay, so that's an issue. So exceptions are the serious issue. Okay, so to handle that exception, we'll study exception handling. Okay, and here we will try to see different ways how you can first we'll understand what is exception, and then different types of exceptions, and then we'll see how we can handle different types of exceptions. And inside that also there are like multiple combinations. Okay, the concept is simple, but I'm saying you that there will be different types of ways how you can write exception handling. There are like lot of ways. Okay, we are going to see that. Okay, it's simple, but it's uh but as I said, that there will be different combinations. Okay, so it will be interesting. Okay, so but let's start. But let me know, is the basic theory clear? Did you get a like practical viewpoint, practical understanding, like what is an exception and why we are studying it? Guys, is everybody awake or anyone sleeping?
Clear.
Okay. Sirisha, are you awake? Oh, hey Sirisha, are you sleeping? Okay, fine. So let's start, or let's try to see few exceptions. Okay, so as I said, in any programming language, right, fundamentally there will be two types of errors. Okay, two types of errors. So one is syntax error, and other thing is a runtime error. Okay, one is syntax error and other one is a runtime error. Now what is syntax error? Syntax error is Let's say you have given a equal to 100. Okay, I'm saying a equal to, I'm checking if a equal to 100, print a. Okay, there is a syntax because I not use colon. Okay, similarly you can have different types of syntax errors. As I said, a, if I, even if you miss say comma, colon, apostrophe, anything, so that will come under a syntax error. Okay, and coming to next thing is a runtime error. Okay, while runtime, if at all you are passing, okay, if at all you are passing, let's say I'm saying a equal to what, int of input, enter a, enter b. Okay, I want to print a by b. Value is a by b. I want to print. Okay, now it will ask, I'm giving 100, I'm giving 0. Okay, now this is an error. Okay, this is a division error. It's a runtime error. Okay, because syntax wise this is fine, because if it's syntax wise there is a problem, it will not run itself, it will not ask me to enter some value. Okay, but while syntax wise it's fine, but while runtime, that means during runtime when the user is giving some value, so then you are falling into error. What is this error? It's a division by 0, because you cannot divide by 0. And while defining the structure itself, if you make some issues, that's a syntax error. Okay, so fundamentally we will have only these two. Okay, either syntax or runtime. The only difference here is user need to fix this. Okay, user need to fix the syntax error then and there itself. Okay, because as per the function or the data type which you are using, obviously you should follow the rules and regulations, and you need to rectify the syntax error. Okay, and it is simple. But coming to runtime, okay, these are the actual exceptions. Okay, whatever exceptions you are facing in the runtime, these will be the actual exceptions. Okay, where we will spend our most of our time and energy. Okay, to handle different types of exceptions. Okay, so fine. So with this basic understanding, let's dive deep into the what I say, the exception handling. Okay, so let me know guys. Okay, so there are like different concepts we will be studying in this concept of exception handling. So I'll be proceeding forward, but in case if you are not understanding anywhere, so feel free to stop and make sure you understand exception handling. Okay, because as I said, so you will be need to implement uh, even on the day one, because the flow breaking is a serious problem anywhere, any programming language. Okay, so fine, let's start. So as I said, in the runtime error, so there could be different runtime error, guys. So for example, dividing by 0 could be runtime error. Or if I want to, what is this, I'm trying to divide a string. Okay, and I want to divide the string, okay, by some integer. Okay, this is also not possible. Okay, this is also runtime error. It's, there is no syntax error, because syntax wise I'm following all the rules. Okay, syntax, what is syntax? See, just to give an idea, syntax is for the Python to start execution. Before execute, see, let's say you have execution. Okay, this is before, this is after. Okay, so before execution it will check syntax, after execution it will check runtime. Okay, during syntax it will not check whether you are giving whether you can divide something by 0 or not. Python doesn't care before execution. Okay, first of all, to allow into its execution part, okay, to make, to operate on that, first of all syntax should be perfect. Okay, what is there inside, whether you are whether it is logically correct, mathematically correct, or data type, if there are any issues, that all doesn't matter before execution starts. Okay, initially it concerns only about the syntax. Okay, but once execution starts, it will check, go into the details. Okay, so the simple way you can understand here is, before execution it will check the syntax error, but only once it is done, only it passes through this gate, syntax error, then the actual execution starts, and then you will have a possibility of runtime error. Okay, so can we have a scenario where we are having runtime error but no syntax error? Okay, guys, tell me, can we have a scenario where we are having runtime error, okay, but no syntax error? Is this possible, guys?
Yeah, Santosh.
Okay, so am I going too fast, guys? Just I want to know. Am I going too fast? Are you guys able to grasp the concepts? Because ultimately this is for you. So if you feel that I'm going a bit fast, so obviously you can raise a flag. Hmm? Is it fine, or should I go a bit slow?
Fine, sir.
Okay. So can we have a scenario where you don't have syntax error, but you're having runtime error? Can we have this scenario?
Yes, Santosh.
Huh? Sorry?
Yes, without syntax, we can get runtime error.
Yeah, no, the other way. These both are same, right? I mean, you're having syntax error, but not runtime error.
Um, if we have syntax errors, it won't even go to runtime execution state. Right? So yes,
Right. So the first case is possible because in syntax will be checked first. Only if it is fine, it will go inside. Execution might in execution it might fail. It can give you a runtime error. Okay. But if syntax itself is having issue, that means you are having syntax issues, then obviously it doesn't enter inside. So you will not face, there is no scope for the runtime error. Okay. So fine. So you should have that understanding. Okay. Fine. So now you can have different types of runtime setters. Okay, for example, if I show you one more example, so let's say you are taking x equal to I want to do some typecasting of input. Okay, enter a number. Okay, and if I want to, let's say 10. Okay, so obviously it will give an error, right? Because I cannot convert 10 to integer. Okay, syntactically it is very perfect. Okay, there are no issues. Okay, but after executing it understood. Okay, execution wise technically there are some issues. Okay, these are runtime errors, so all these are exceptions. Okay, so just try to understand. Okay, now let's try to take exception handling concept one by one. Okay, step by step. So try to understand. So what all we are getting are, these are all different types of exceptions you are facing. Okay, and we will see the way how you can stop this. Okay, so this is one time exception. Okay, this is one time exception. This type error is another value exception. Okay, value error is another value exception. See, here only you have three different types of exceptions: zero division error, type error, value error. Okay, right. So mostly this exception handling concept is applicable to the runtime errors. Okay, as I said, because syntax errors we don't need to any do any separate logic. So if you just correct the exceptions, it will work fine. Okay, but now fine. So if you go by the definition, right, guys, if you go by the definition, okay, just from the interview point of view, if they ask you what is an exception, so okay, so the simple way you can understand is any unwanted and unexpected event that disturbs normal flow of program is called exception. Okay, any unwanted or any unexpected events, okay, that disturbs the normal flow is called an exception. Okay, so as we have seen, there are like different types of errors: zero, type, value, like that. There could be many. For example, end of the file error you will see in the file handling, and file not found error. So if you're trying to access or open some file which is not yet present, okay, then you will have some error. Okay, and there are different types of exceptions. Okay, for example, yeah, so I will show you. See, so as we have seen, is my image visible? Can you see my image?
Yes, sir.
Okay, fine. So as you can see, we have got some of these errors, right? So I think we got this zero division error. Okay, so like that, and there is some more called type error we got, and value error we got. Correct. So as you can see, zero division error, type error, value error. Okay, so this is a complete mind map of the exception concept. Okay, as you can see, the in you will have one at the high level, so this all comes under the base exception class. Okay, inside that you have different types of exceptions. Okay, so in arithmetic you have the zero division error, float error, okay, overflow error, so different types of error. And you can have the end of the file error, okay, and os error, operating system error, okay. So while you are running, if it is based upon the system, okay, then you can have type error, as we have seen, value error. Okay, these are different types of exceptions that are possible. Okay, so and we are going to see how we can handle this. Okay, fine. And just to give an idea, so it's actually it's highly recommended to handle any exception. Okay, so because yeah, because you should not miss. And if a flow is completed peacefully, right, it's called graceful termination. Okay, if at all, and any code starting from line 1, if it is executing till line 1000, it's called what? If it is terminating like that, it's called graceful termination. Okay, always our aim should be to have the code terminating gracefully. Okay, so now let's see few examples. Okay, so yeah, so coming to here, so what we can do here. So now let's try to understand handling the exception. Since we had some basic type of some basic idea, we got what is an exception, different types of exception, and the overall structure. Okay, the of the different type of exceptions. Okay, now let's try to start understanding how to handle these exceptions. Okay, how to what to learn so that we can try to bypass the code or just to raise an exception, and so that the other code does not get disturbed. Okay, so fine. Okay, see, before that, you need to understand this concept called exception is what deviating from normal flow. Exception handling does not mean repairing the exception. Okay, we have to define alternate way to continue the rest of the program normally. Okay, that's the concept. Okay, exception handling does not always mean you are solving the problem which you are getting over there. Okay, we are only trying to create an alternate way or bypass that issue and continue the rest of the program. Okay, for example, if you are having something dividing by zero, this is a problem. How can you solve it? Nobody can solve that, because it's not possible dividing something by number by zero. Okay, so exception handling is, we are not, it's not exception solving. Okay, it's just exception handling. That means you want to handle that situation. Okay, handling situation could be multiple ways. Okay, you can bypass it, you can just raise an what do you say, warning over here. So you can do different things. Okay, so that you want to continue the rest of the program normal. Okay, that's fine. Now coming to the actual code. Okay, what we are trying to solve here is, so in Python, as I said, everything is an object, right? So as we have seen, everything in a Python is an object, whether it's a function, data type, everything is an object, and everything will have its, if an object, it will have some class. Okay, if it is an object, it will have some class associated with it. Okay, so here exception also is an object. Okay, every exception in Python is also an object. It will have a corresponding class. Okay, it will have a corresponding class. Okay, so for example, this issue is belonging to the value error class. Okay, so this is one class. Okay, value error object. So if at all this object, okay, when you are passing, trying to do some int typecasting on integer, so that type of exception will come under what class? Value error class. Okay, similarly you have some zero division class. Okay, all these are classes. Okay, and because everything in Python is an object. Okay, that you should never forget, right? So it will try to trigger to the corresponding class. Okay, we'll try to see that. But fundamentally what you have, how you can handle the exception is, first there are like different steps over here. First thing is, you have something called as try. Okay, so it's called try block. Okay, now we are actually entering the actual concept of how you are handling the exception. Okay, so the way how you can handle exception is, first thing is, you can write something in the try block. Okay, what is it called? It's called try block. Okay, so in try block, how you can do. Okay, for example, see here, I am executing this print 10 by 0. Okay, I'm just trying to do that. Okay, then what I'm trying to do, I am trying to just enter this. Okay, what it is giving, it is giving me error. It is giving me what? It is giving me some error. But if at all you have something called as try, okay, if at all you have something called as try, okay, so here, okay, you have except, okay, try except, fine. So instead of directly writing it over here, you can put it in something called as try block. Okay, this is called try block, try block. Just like you have if block, if else block, this is try block. And then as you can see, you have something called as what? You have something called as except block. Okay, you have something called as except block. So try except. Okay, you will have one more thing also, but let's initially say try except. Try except are two blocks which will help us essentially handle the exceptions, any exceptions. Okay, so what it will do, we'll try to see whenever you're writing, if you can use try block and write your code over here. Okay, and you can write except, okay, and you can print something. Okay, see what it will do when I run this, it is not, it is not terminating abnormally. Okay, the terminology is important over here. This type of execution is called abnormal termination. That means this is not normal. That means it is stopping over here. It is when the error is printing on the console, when the Python interpreter is printing the error on the console, that means the program flow got halted. It stopped over here. It's not executing anymore. Okay. Even though there is some error, that is the most important thing. Even though there is some error inside, that means 10 by 0, it is stopping. But here, when you are using try except block, so you can write whatever the code you want to execute in the try block. Okay, and you can write except block, okay, which gets executed if at all there is some error. Okay, so what happens over here is the interpreter tries to first go into try block. By default it will enter here. Okay, so this is not without any condition, right? So this is not like if else. Okay, so it will try to execute, it will enter the try block. Okay, and if it is by 0, if you're trying to divide, okay, by 0 you are trying to divide, right? And if at all you are having some error, it will directly trigger the except block. Okay, if at all you are having an error, it will directly trigger the except block, and what, it will print the error. Okay, that's why you are seeing the error. Okay, but the important point here is the issue is there here also, the issue is there here also. Okay, here also you cannot divide by 0, here also you cannot divide by 0, but here it is abnormal termination and this is normal termination. Okay, because it is not, the flow did not continue. Even if you write something here also, you will get the flow. Okay, hey Sirisha, what happened? Sirisha, are you there? Not sure. Okay, you there, Sirisha?
Yes, sir.
Can't hear you. Okay, fine. See, so I'm trying to what I'm trying to show here is, if it is failing over here, as you can see 10 by 0, good morning will not get printed. Okay, I cannot see good morning printing over here. Okay, but if I try to print here, good morning is getting printed. Okay, that is a way how we have handled the exception. Okay, isn't it interesting? Because I don't want to, okay, there might be some issue, I don't know, because I don't know what the user enters the input, because some fellow who doesn't know max, if he's entering the division by 0, because of his mistake, I don't want the whole program to stop. Okay, so after this, if I have after 4, if I have till 100 lines of code, all those got stopped, because as you can see, this is not getting printed. That means nothing is getting executed after this. Okay, it got stopped over here. But here, as you can see, we are cleverly handling the exception so that, okay, there might be possible for some issues, okay, dynamically, so I will handle that. So if you are getting some exception, it is going to trigger this except block, and it is printing that, hey, you are getting some error, and after that it is not stopping, it is continuing its flow, it is printing good morning, whatever you write after here, it will execute all those. Okay, this is called normal execution, okay, or normal termination. If it terminates, right, in eventually if it terminates, it's called normal termination. It's called abnormal termination. Okay, so as I said initially, so our goal is always, what all we are doing, right, in one single line, you should always understand whatever you are doing in exception handling, it is to achieve only one single goal. Okay, to make sure that the flow is normally terminated. That means the flow is never breaking in between. Okay, and you don't want it to be abnormal termination. Okay, abnormal termination is the biggest issue. Okay, so our a main what all you study, like you will study try, except you will study one more, you will study different combinations. Okay, we'll see different lot of examples over here, but everything we are trying to achieve for one single purpose and goal, to make sure that the flow is normally terminated. Okay, to bring it to the end point. It might face some issues. You might face some issues. Okay, just to be bit philosophical, it's similar to life also, right? So in life also, let's say you will face some issue. Okay, if you stop here, obviously you don't know what happens tomorrow, right? So if you stop and just keep crying over here, so who knows what's going to happen? Some surprise it might be waiting, right? If you are trying to just handle, okay, if you're just trying to bypass, okay, handle in the sense it's not solving. No, not every time you will be have you will be able to solve some problems in your life. Okay, but you can just handle it. Okay, you can just bypass it. Okay, you can just deviate. Okay, you can just put it aside, and if you continue, you might you can get, see, you got good morning. Okay, you might get some wonderful messages. Okay, forward. Okay, similarly the flow should not break. Fine. So that's the concept over here. So now you go a bit technically. So now if I do 100, okay, if I do 100, see, try to understand, this except block gets triggered only when there is exception. Okay, only if there is an exception. If there is no exception, it will not accept, it will not trigger. Okay, now 10 by 1000 is perfect, so that's why it gave you answer 0.001. It gave you answer. After that, it is printing good morning. Clear? It did not execute, it did not go into except block. Okay, always here for in the exception handling, right, you should be continuously cautious, like which block is getting executed. Okay, that's very important. Okay, sometimes, few of the blocks will execute it. There are different combinations, as I said, right? I'm repeating multiple times, there will be different number of combinations. Okay, and it will be very interesting. So always keep your eyes alert and see which block is getting executed. Okay, so here only the try block, if there is no issue in the try block, then exception block will not execute. Okay, so that's fine. So here here no issues, 0.01 good morning, that's fine. But if at all you are having some issues, only if at all you are having some issues, right, only then this is a one more issue. Okay, so that's why then it will trigger what? Trigger both the, sorry, trigger the except block, and after that the flow continues. Okay, is this clear, guys? Are you just trying to able to understand?
Yes, sir. Clear.
Okay, so now fine. So I'll just give show you a flow, and then we'll continue tomorrow. But see, uh, there is one thing interesting over here. See, yeah, so actually exception handling is very interesting, as I say. So okay, see, let's say you are having try. Okay, inside that you are having statement. Okay, I'll write statement 1 s1. We have statement 2. Okay, we have statement 3. Okay, for example. Okay, now see, I'm having except. Okay, observe carefully, and you will have statement 4. Okay, and then you have outside this. Okay, statement 5. Okay, statement 5. Okay, statement 1 to 3 is inside try. Okay, try. Statement 4 is inside except, and statement 5 is completely outside. Okay, now just tell me, if there are no exceptions. Okay, if there are no exceptions, what all will run? If the, I mean, if it's normal
S2,
termination. Okay,
S3,
let's use these words, normal termination, abnormal termination. Okay, so if it is a normal termination, first case 1, normal termination, what will run? Yeah,
S2, S3, S5.
yeah, you can just say 1 2 3 4. You just say 1 2 3 4 5, something like that. Yeah, you're saying 1 2 what? 1 2 3 5. Perfect. So it will print 1 2 3 5 because normal termination, that means no exception is raised. So 1 2 3, so this will get bypassed because no exception, then the flow continues. Okay, this is perfect. Now case 2, exception at statement 2. Now If at all
One,
you're having an
four,
exception
one,
statement too,
145.
huh?
Exception at 2, right?
Right.
So 145.
Okay, 145. Okay. But now, okay, fine. So correct. Now exception case 3, exception at S3, then 1, 2, 4, 5.
45.
Okay, fine. Now exception at 1,
It will directly go to S4 and also it proceed with 5. 4, 5.
4, 5. Okay, that's perfect. This is simple case. Okay, what we have seen is a simple case. Now we will see the extension of this, but fine. Do we have time, Sirisha Meghana, or is it time for your college? Hmm? Guys, can you confirm if you can extend for 5 to 10 minutes, or you want to continue tomorrow? First,
We can extend, sir, for 5 to 10 minutes.
okay, fine. So this is just small concept. So because in this flow only you should understand that. Otherwise you will miss that. Okay. See, now you are having this error, right? Okay, it is handling. Okay, that's fine. But now this is what, this is general error. This is general exception. See, I'm having, when I do 10 by 0 also, it is, see, when I'm doing 10 by 0 also, it is printing this error. Okay, it is going into this. If that is one type of error. What was that error? Zero division error. Now if I do int also, it is printing me error only. Okay, what is this this int? Okay, as you can see here, uh, what do we have? It's unsupported type error. We got some type error. Okay, so for all the errors it is going into one exception. Okay, because we have written only one. Okay, but let's say you want to specifically address that exception. That means if at all I'm having 0, if at all I'm having 0, okay, I want to go for only that particular exception, because for 0 we have already clearly defined something called as zero division error. Okay, I have clearly defined something called as zero division error. Okay, so why shouldn't we use that? Okay, so obviously we will use that. Now here, print 10 by 0. Okay, then except zero division error, I'm saying. Okay, then print error. Now here, if I if I print, I'm saying zero error. Okay, so I'm getting zero error. Why? Because this error 10 by 0 internally it is causing what? Zero division error, as you can see here, right? So it will create, it will exception will occur here. The reason why it is not showing is we are handling it. If you're not handling, if you're just writing 10 by 0, obviously it will have here, right? So internally this will happen, and it will see, hey, this is zero division error. And then to handle this zero division error, we are using this except zero division error. As you can see, what we are using here, instead of using simple except, here we did not use anything general. So but here we are going with a specific exception. Here I'm saying except handle this exception. That means handle only this exception. Apart from this exception, it does not know any other exception. Okay, so that's why you're specifically mentioning, hey, handle zero division error. So then if at all the zero division error occurs in this try block, okay, if at all a zero division error occurs in try block, only then it will come to this exception block. Okay, so as you can see 10 by 0, as you can see 10 by 0, so it is having zero division error. So that's why it is triggering this zero division error. But if I do 10 by int, okay, but if I do 10 by int, it is not handling. Hey Sirisha, are you good? I see you are connecting, disconnecting. Are you able to hear me, or are you following the class? Sirisha, are you following the class? Okay, fine. See, the important point here is, earlier this except is able to handle all the exceptions, because if even if I do int also, it is handling, as you can see. Okay, yes, yeah. 10 by int also it is able to handle. Okay, whatever you write, it is able to handle. Okay, because I did not give any specific exception. That's why this will handle all the exceptions. Okay, but here I'm this exception is only zero division error. That means it will handle only zero division error. That means only if I do 10 by 0, then it will handle, it will say zero error. But if I do some other exception, it cannot handle, because this is not that exception. Okay, so that's why it is giving error. It is saying a type error. Okay, clear? So if you are using a specific exception, it will handle only that exception. Okay, otherwise what it will do, now this is what, guys, tell me, this is what, normal termination or abnormal termination? This is what, normal or abnormal termination, which what we are seeing over here. Guys, you don't get this.
Normal.
It's
Normal.
normal termination.
Why normal? See,
Abnormal, sir.
Python is printing error on the console, man. The Python is printing error. If you are seeing the error, that is an abnormal. Because what happens, abnormal means what, normal means what. So that means, just imagine you are writing this same thing in you are putting this code in .py file. Okay, and you are deploying this code. Okay, if you're deploying this code and it is running in the runtime, okay, in the web application you are running, and if this error comes, and if someone is passing int, okay, and you are trying to divide 10 by int, okay, and there is no exception to handle this int, because this is only zero division error, it cannot handle this type error. Okay, obviously what it will do, Python will throw this error on the console and it will just stop it. It will stop, it will halt the complete execution. Then is it normal or abnormal? That is abnormal. Are you guys trying to understand what is normal, abnormal?
We consider it as a syntax error.
Sorry, Sisha, I didn't get what is.
Consider it is as a syntax error, sir, or runtime error.
This is runtime error. No, but where is the syntax error? How, like, syntax error, where you are able to see, because print 10, syntax is perfectly fine. Syntax is perfectly fine, because 10 is no syntax error, slash is perfect. I did not miss any quotes, I did not miss any braces. See, if I remove this brace, that is syntax error. Can you see? Or if I remove this quotes, that is syntax error. Can you see? Unterminated literal. Okay. But as for the syntax, I'm following all the rules. 10 is syntax, int is syntax, slash is syntax, print also I'm using the braces. If syntactically it is perfect. Okay.
Yes, sir, got it.
But if I run after perfect syntax, if I'm getting some error, that is a runtime error. This is type error. So see, guys, I'm repeating again. If at all the Python is printing an error to the console, so this is console, right? So if at all it is printing an error, that means it is not able to handle it. It is breaking in between. Only when it is breaking, it will throw the error. Okay. In simple words, if at all you are seeing the error, that means what, Python is not handling error. Because if it is handling error, obviously you will not see the error, right? For example, here if you see 10 by 0, if I print 10 by 0, 10 by 0 is an error. Obviously 10 by 0 is definitely an error. Why? Because you cannot divide some number by 0. It will definitely raise what, zero division error. But here we are handling that zero division error. So if you run this, you cannot see the error. Even though there is an error, you cannot see that, right? The error is happening here, the issue is still there, but you are handling that in this exception. How you are handling? You are saying, hey, except zero division error, you are handling that and you are putting some message. Okay, that's why you cannot see the error here. This is a normal termination. This is a normal termination because you cannot see any error. But if in the same example, if I change this to int, right, now there is an error happened, that is type error, and the Python is not able to handle that because there is no except block for the type error. There is only except block for the zero division error. That's why it doesn't know where to go. That's why it will throw the error to us. It will say, hey, I cannot handle this error, there is no except block for me, I don't know how to solve this, you only take care, it is saying, right? That's why it is throwing error. That's why when you are throwing error, that means it is breaking, the flow is breaking. Okay, that's why this is abnormal. Abnormal. How I prove this abnormal is, see, if it is normal, obviously it should print the all the statements below, right? I'm printing some next. Is it printing next? No, you cannot say next, because it is breaking over here and the flow is getting stopped. But if at all I write 10 by 0, you can see, even though this is error, but we are successfully handling the error using this except block, and it is going here, 0 error it is printing. Okay. And next it is continuing the flow. Okay. This is normal execution. That means there is no error. It is handling the error. No error in the sense error is there, but we are handling the error and the flow is not getting terminated abnormally. This is a normal termination. But if at all you are seeing an error, something like this is abnormal termination. Okay. So guys, tell me honestly, did you guys understand what is normal termination, abnormal termination? If you do not understand, that's completely fine. I'll tell 2 or 3, 4 times. But you should be clear with the exception handling. Otherwise, right, tomorrow class would be very, very confusing. Okay, because if the basics are not clear, if I start mixing these things and come up with different combinations, right? So it will be completely crazy. So that's why I'm taking it slowly. So fine, if you didn't understand, that's fine. But let me know. Are you clear with what is normal termination, what is abnormal termination? Everyone.
Yes, sir, clear.
Okay, fine. So let's stop here for today. Fine. So just keep in mind what is exception, what is simple syntax. Okay, you can forget about the syntax error because we don't handle it in the exception handling. Okay, mainly this is for the runtime error. Okay, so in the runtime error, how we are going to handle, we are going to see. Okay, so as of now, we have seen a simple example of try block and except block. Okay, tomorrow I will try to revise this again, and we will see different kinds of exception blocks. Okay, and then let's try to understand it. Okay, fine. Tomorrow join sharp at 6:30 because we need some time to cover different combinations. Okay, so each minute counts tomorrow. So let's meet tomorrow, guys. Yeah, chalo. Thanks for joining.